Welcome to another episode of eThekiwni Matters. My name is Zimbili Mazibuko, your host. Today we have a special guest, Jooste, who is a senior manager at development engineering in the eThekiwni municipality's engineering unit. He is the proud recipient of the Best Technical Innovator Award at the Engineering Unit Recognition Awards for his groundbreaking work on the Bellington Heights Greenfield Housing Project. Mr. Jooste, welcome to eThekiwni Matters.
Thank you.
What inspired your design? Tell us more about your design.
Okay, so the original plan for the sewer layout was that we had to cross the Umsatazana River, and the floods in 2021 proved that it was not a good option. We would have lost the whole infrastructure if we had proceeded to build it along. So we had to look for an alternate to the original design, and the alternate was roughly a kilometre away, which required us to cross a ravine to get the connection to work. So we then looked at options of, we had the bridge already in the document for crossing the river, but that was a small component compared to where we had to go now with an additional kilometre of sewer. So we then looked at cost-saving interventions to offset the cost of the additional length of sewer, and that got us thinking as to how can we save costs. And the one cost saving was the pipe bridge, where we were able to save another 380,000 Rand, which then went towards offsetting the cost of the additional length of sewer required to connect the sewer.
Could you break down the specific cost components that contributed to this reduction?
Okay, so with the revised design, we went from having to have 7 piers to only 4 piers. And the height of these piers ranged between 12 and 15 meters. So straight away there was a cost saving in not having to construct additional 3 piers at that height. So there's the costs involved. It's obviously concrete, there's reinforcing, there's time and costs as well. So we cut the time down from 28 weeks for the conventional to 14 weeks for the revised design. So just in those alone gave us a significant cost saving in both time and resources, so the contractor could then allocate the resources to other components of the project on the ground while not having to concentrate them on doing the sewer, the pipe bridge.
Interesting. Tell us about the environmental benefits of the system.
Okay, so the environmental benefits came as almost as an added plus. It wasn't a direct consideration in the beginning. So the environmental, obviously, we weren't having to go and excavate another 3 bases in the sensitive valley line. So, but the main environmental thing is that we then were able to space the piers so that we didn't have a pier sitting in the deepest part of where the water would flow. So the pier spacings now became 11 meters apart instead of 5.5 meters. So the possibility of an obstruction with something coming down the ravine in the flow was negated. So damage to the environment of causing the bridge to possibly be washed away or flood has been mitigated by the spacing, and therefore the environmental benefit is quite big from that point of view. But also, when you go down to excavate for the bases, you have equipment having to go down and excavate, so you weren't having to have a large amount of equipment. And then also in the construction process, you're erecting scaffolding, so the guys are then damaging the area around the columns, the column bases. So with having 4 bases instead of 7, we mitigated the impact on the natural environment around the bases.
And how adaptable is your design to geographical and hydrological conditions?
Okay, so hydrologically, it's very adaptable because the shape of the columns and the piers it's round, so that immediately facilitates water flow around them. So hydrologically, it's not a massive innovation or it doesn't have a massive change. So geographical, we look at obviously the height of the columns, and these were designed to 15 meters. So anything that's higher than that would have to obviously be redesigned or looked at by the structural guys. But so access to actually get to the where the bridge is going to be is a massive geological consideration, because you need a crane to be able to come in and lift the beams into place, and obviously if you can't get access with the crane, then it's not a one-size-fits-all solution, but it does definitely have its adaptability. For instance, if you had a short crossing of 10 meters, you'd require 2 piers instead of 3, because it can span that distance and not having to build one in the middle of a stream or something like that. So from that point of view, it's adaptable, but obviously geotechnically, we need to determine a good founding base. So that depends also on then how deep you have to make the foundations, which then could also affect the height of the columns.
Did you encounter any challenges during the development and implementation of this design?
The challenges we had were mainly we found rock at a reasonable level, so we only had to go down about 1.5 meters to find a good founding base. So that wasn't the issue. But in developing the design, the beams, the I-beams are 11 meters in length, but a galvanizing tank can only take something up to 6 meters. So we then had to cut the beams in half and get them galvanized. Eventually they had to be galvanized because they're out in the elements. So from a rust point of view and a maintenance point of view, they had to be galvanized. So we then had to cut them in half and then come up with a joining design, which then had to be approved by the structural engineers again, so that the beams wouldn't sag in the middle and would be able to withstand the process. So that was one of our challenges. But we also, you're changing from the norm. So, and development engineering is not a service owner department. So we're constructing things on behalf of human settlements, but the sewer and the pipe bridge gets handed over to the waste to EWS to operate and maintain. So obviously we had to consult with them and get their buy-in to what we were doing, because of the possibility that it can be replicated going forward and suitable. So we had to work quite closely with their design engineer at the time to get his approval to implement the change. Other consideration was that being steel, it has a scrap value, and a theft is a possibility as well. But given that the structure is between 12 and 15 meters high and it's only 250 millimeters wide, for someone to access that and to get the pipes off it and get the scrap metal value, it was deemed to be a suitable solution.
Would you like to add anything else about your design?
Not really. It was just, mine was the idea, but there were the other guys who dealt with the structural components who made it happen. But I had the notion that, yes, we could do this. Is it possible? And then the structural engineers then confirmed that, yes, this size I-beam is suitable and those columns are good enough for what's happening. So I might have had the idea, but the brains behind putting it into, is part of the team. And we have a very good team in engineering unit, because the structural guys are from our roads provision department. There's a bridge department there, and they were very good in assisting us.
Just out of curiosity, how long did it take to work on this design?
I think it was within 2 months we had the answer from going through the processes. So it was quite a quick turnaround for us.
Mr. Jooste, thank you very much for coming through to eThekiwni Matters today.
Okay, thank you very much.
That was Doug Jooste, who is the Senior Manager at Development Engineering in the eThekiwni Municipality. My name is Zimbili Mazibuko. From myself and the entire team, it's goodbye till next time. Don't forget to like, to subscribe, and to share.